Hello fellas, welcome back. This is the last video of week 3. It's actually should be a kind of short one, and it's just continuing on about trig functions, and we're going to look at domain, we're going to look at range, and talk a little bit about periodic functions. So let's get started. Let's talk about the domain and range of the sine and cosine function. Remember we were talking about angles, and we were talking about unit circle, and let me get my pen. One thing that I hope you understand is that, sine and cosine are points on the unit circle, and they're defined like that. And the point there at some angle theta, and I can say that the x-coordinate is cosine and the y-coordinate is sine. But when I start talking about domain, is what are these angles that I can plug into the sine and cosine function? Well, as we saw before, we can keep going around and around this thing as many times as we want. We're going to repeat ourselves, but if I go from 0 to 2 pi, I'm going to go through every value at least once. And then if I go 0 to 4 pi, well, I'm just going to go around this thing twice. All right, if I go negative pi, I'm going in this direction, this way. Okay? So there's really no restriction on what value of theta I can put in. I'm just going to keep going around that circle. So the domain is going to be all real numbers, okay? So there's no restriction. And what about the range? Now understand that the range, the value of sine and cosine is always going to be on this unit circle. And the maximum value x is going to have on the unit circle. Remember, the unit circle is x squared plus y squared is equal to 1. The maximum value that x can have is when y is equal to 0. And in that situation, x is equal to 1. Okay, so x is going to go from negative 1 on this side, comma 0, whoops, to 1 comma 0 here. So that's what x is going to go from, and y is going to go from 0, from negative 1 to 1. So what the maximum y and minimum y are negative 1 to 1. So the range for both of them always going to produce a value between negative 1 and 1, and I can include those two endpoints there. Okay. One other note I want to make sure that you guys understand is whenever you're doing trig on your calculator, make sure that you know what mode you're in. It's going to make a big difference. If you're in degree mode and you're supposed to be in radians, you're going to get the wrong answer every time. So make sure when you're doing a problem, make sure you understand what the problem is looking for in terms of angles, whether it's degree or radians. And make sure your calculator is in the correct mode as well. Okay. Let's talk a little bit about period. Period is how often is the function going to start to repeat itself? Okay. And if you think about the sine and cosine function, it's going to be every 2 pi. For example, I'm going to go through this whole cycle once between 0 and 2 pi. Then I'm going to be right back to this point right there on my unit circle. Then when I start going from 2 pi to 4 pi, I'm just repeating myself. And then if I go from 4 pi to 6 pi, I'm just repeating myself again. So the function is just going to keep going and doing the same thing over and over and over again. Okay? And that's going to occur. It's going to go through one complete cycle every 2 pi for both the sine and the cosine. We say that that is the period for these two functions. Okay? Some of the other functions, the other trig functions we talked about are also periodic. And we'll talk more about them later. But it's really important to understand that the period for sine and cosine is 2 pi. Let's talk a little bit more about the periodic functions. Periodic function, this is the period c. Okay, so if I have a function x plus c, and c is the period, it's the same as f of x. In other words, if I had f of, not sure why my pen's not working here. Well, anyways, let me just go down here. There we go. If I have f of, whoops, yeah, let me just erase that. Let's go. Let's look at the sine function first. Okay. Let's look at sine. If I have x plus 2 pi n, and x this is just simply going to be equal to sine x. In other words, if I pick any value, let's do an example, 9 pi over 4, okay? And if you understand where 9 pi over 4 is, I'm going to actually go around the unit circle around here. It's not a great circle, but 9 pi over 4, I'm going to go around twice, okay? Because this is going to be, I'm going to go around once, I'm sorry. This is going to be 4 pi over 4, this is going to be 8 pi over 4, and then I'm going to end up somewhere over here, okay? And so I basically did this once, and then I finished right there. Well, my y coordinate here is the same as if I just went like this, pi over 4. And that's what this is saying right here. So the sine of 9 pi over 4 is the same as sine of pi over 4, which we know is root 2 over 2. Okay? Hopefully you guys understand that. Let's do another one. Let's look at 13 pi over 2. Again, it's going to take some time to understand and get the hang of this. Let me see. Pen's acting funny here. Well, let's look at this. I can rewrite 13 pi over 2 as pi over 2 times 3 times pi over times 2 pi. In other words, to get the 13 pi over 2, I'm going to go around the circle 3 times. Once, that's 2 pi, that's 4 pi, that's 6 pi, and then I come one more, that's going to be 13 pi over 2. So I just went around 3 extra times, and that's the same as pi over 2, and we know what the sine of pi over 2 is. The sine of pi over 2 is 1. Okay? Hopefully that makes sense. And I can do the same exact thing for cosine. I can say cosine of x plus 2 pi n, again, because 2 pi is my period, is equal to cosine x. So if I have cosine of 6 pi, I can rewrite that as cosine of 0 plus 3 times 2 pi, which is exactly what we did up there. I simply go around this thing once, twice, 3 times. I'm right back here, okay, right back along my x-axis. I know what the cosine of 0 is. It's equal to 1, which is going to be equal to cosine of 6 pi. Okay? Here's a negative 1. If I go negative 9 pi over 4, now I'm going in the opposite direction. Okay? And so basically what I'm doing is this. I'm starting along my positive x-axis. Now I'm going to go clockwise because it's negative. This is 4 pi over 4. This is 8 pi over 4. This is 9 pi over 4. I'm right there. I know that the cosine of that angle is going to be root 2 over 2. Okay? Hopefully that makes sense. Let's talk about even odd properties. Again, hopefully you guys remember what the even and odd properties are. Even functions, remember f of negative x is equal to f of x. That's property of even functions. Means it's reflective about the y-axis. The cosine function and the secant function are both even functions. Okay? The others are odd functions. And remember, an odd function is f of negative x is equal to negative f of x. Odd functions are reflective about the origin. Okay? And all the others are odd functions. Let's do an example here. If cosine of theta is equal to 3/5, what is the cosine of negative theta? Well, again, using the fact that cosine is an even function, cosine of negative theta is going to be equal to cosine of theta, so I simply get 3/5. Okay? This is because it's an even function. What about secant? What about secant of negative theta? Well, if you think about secant of negative theta, again, secant's an even function as well. So secant of negative theta is equal to secant of theta. And remember, secant of theta is 1 over x, or 1 over cosine. So it's 1 over 3/5 or 5/3. Now what happens if I want to know about sine of negative theta? And I'm giving you information that theta is in the first quadrant. Okay? So first thing we want to do is we look at the unit circle. Here's my equation. If my x value is 3/5 squared, now I want to find out what my y value is. And you guys should know, you should look at this and be able to see that this is going to be 4/5. Okay, you could solve this equation out. and get that it's going to be 4/5. And that means that the sine of theta is 4/5. All right. And now what I want to do is make use of the fact that sine is odd. So if sine of theta is 4/5, sine of negative theta is negative sine of theta. This is the fact that it's odd, and that'll give us negative 4/5. Okay? Here's some practice. Again, look at those examples. Here's some more problems to do. Again, I can't tell you how important it is for you guys to make sure you learn your unit circle. That's critical. Okay? Summary of this video basically talked about the domain and range of sine and cosine. The domain of sine and cosine is all real numbers. The range is from -1 to 1 inclusive. And we found that the period of both the sine function and the cosine function is 2 pi. And so that the function just keeps repeating itself over and over and over again. Okay? We saw that sine, cosecant, cotangent, and tangent were all odd functions, and cosine and secant were even functions. Okay? It's now just time to practice, fellas. It's time to finish up that take-home test, or actually take a problem set for week 3, and then get ready for your midterm exam. All right? Any questions, make sure you're emailing me, and we'll have some review sessions to get you guys ready for the midterm exam. Okay? Have a good day.